In the previous video, we were looking at a galvanic cell like this one over here, and we identified zinc electrode as anode, the site of oxidation, and a copper electrode was called a cathode because it was a site of reduction. However, it is fair to ask why it is not the other way around. The answer lies in the relative activity of metals. If you look at the table J in your reference tables, the activity series of metals and nonmetals, you will see that zinc is higher in the activity series compared to copper. So zinc is more likely to be oxidized. It's more active metal. It's more likely to shake off its valence electrons and send them on their mission to go and reduce something. So now when you are asked to analyze a voltaic cell to identify which electrodes serve as an anode and which one as a cathode, you need to check table G, the activity series. The metal that is higher in the activity series will be the anode, the one that is oxidized, and the metal that is lower in the activity series will be a cathode, the site of reduction. And electrons lost in oxidation will be running from the anode to a cathode. Let's analyze this galvanic cell over here. Okay, we have two electrodes made out of copper and silver. If we check table J, we will see that the copper is above silver in the activity series. It means that copper is a little bit more active than silver and is more likely to be oxidized. Copper electrode will be an anode. So our electrode made of silver will be a cathode, the site of reduction. Since now we know which electrode is anode and which one is a cathode, we can identify the flow of electrons. They will be running from the anode, copper, to the cathode, silver. Now, let's write the oxidation half reaction that takes place on the copper electrode. Copper is getting oxidized, it is losing electrons, becoming a copper ion. 2 electrons are lost in the process. Now, reduction half reaction takes place on the silver electrode. Let's write it down. Silver ion accepts an electron and turns itself into atomic silver. 1 electron accepted in the process. So 2 electrons are lost, 1 accepted. We know that that cannot be. We should have the equal number of electrons lost and accepted. So clearly 2 electrons will be reducing not only 1 silver ion, but it will reduce 2 silver ions. 2 silver ions are reduced, 2 electrons accepted, 2 atoms of silver are formed. The 2 half reactions that we wrote over here can be fused into the overall redox reaction that is happening inside of this cell. Let's make a quick review of what we were able to identify about this Voltaic cell. We were able to identify copper as the electrode that will be site of oxidation. So copper electrode is an anode. While silver will be a site of reduction, this electrode will be called a cathode. We can say that the electrons would be running from the left to the right because electrons are produced, released, lost on the anode, and they are traveling through the wire towards a cathode. Since electrons are running away from the anode in Voltaic cell, anode said to have a negative charge. It's repelling electrons, and they are running towards cathode that said to have a positive charge. We wrote oxidation and reduction half reactions that are happening at the electrodes, and then we fused those reactions into the overall reaction. We understand that the number of electrons lost should be equal to the number of electrons received, which allowed us to correctly balance our equation. We also can say that over time, mass of anode of copper electrode will be decreasing as more and more copper atoms are oxidized and become ions in the solution. And the mass of silver electrode will be increasing as more and more silver will be reduced and atoms of silver will be accumulating on the electrode. Over here, we can see that there is only single silver in this jar, but clearly it is implied that it's not a single silver. There is a lot of silver ions swimming in there. So there is plenty of ions of silver to be reduced and turned into the atomic silver. Okay, a few additional questions. For example, what is happening to the concentration of copper ions in this solution? Well, as the oxidation takes place, the more and more atoms of copper get oxidized, there will be more and more copper ions in the solution. So the concentration of copper ions in the solution is increasing. And the mass of the electrode itself is decreasing, because this is how ions of copper are formed. The question number 2, what is happening to the concentration of silver ions in the solution? Okay, since silver ions are getting reduced and turning themselves into the atomic silver, there will be less and less ions and more of electrode. So the mass of the electrode will be increasing because the silver ions are getting reduced and atoms of silver accumulating at the surface of the electrode. What is the direction of the positive ion flow in the salt bridge? Okay, positive ions will be attracted to a negative solution. We probably will have increase of the negative charge right here in the right jar, because there will be less and less positively charged ions in it as the ions of silver are getting reduced. So positively charged ions will flow towards this jar on the right, while our negatively charged ions will try to reach our solution on the left. Because of the increasing concentration of the copper ions, here there will be buildup of the positive charge, and that positive charge will be attracting negatively charged ions in the salt bridge. So you can see that even from a very small and simplistic representation of the voltaic cell, we can tell a lot about the voltaic cell, its structure, the direction of the flow of electrons, and so on. So let's analyze this voltaic cell. After checking table J, activity series of metals, we can see that magnesium is much higher than silver on the activity series, so that will be our anode, the metal that is more active and that is ready to be oxidized to shake off valence electrons and send them on their mission to reduce something. Since magnesium is an anode, silver will be a cathode with the positive charge. Electrons would be running from left to right from the anode of magnesium towards the cathode of silver. Let's write the reduction and oxidation half reactions. Right here, magnesium will be losing electrons, turning itself into magnesium ions. 2 electrons are lost in the process. Silver will be oxidized and turning itself into atomic silver. 1 electron is accepted in the process, but the number of electrons lost and accepted should be equal, so we do know that 2 ions of silver will be reduced by 2 electrons and 2 atoms of silver are formed. Now we can fuse these 2 half reactions into the overall redox reactions that is taking place in this galvanic cell. We can predict increase in the concentration of magnesium ions in the solution on the left and the decrease in the concentration of silver ions in the solution on the right, as the magnesium is getting oxidized and silver ions are getting reduced. Based on this, we can expect buildup of the positive charge here and buildup of the negative charge here, which helps us to predict the flow of positively charged ions towards the right jar over here and the flow of negatively charged ions in the salt bridge towards the left side of our voltaic cell. We also can say that the mass of magnesium electrode will be decreasing and the mass of silver electrode will be increasing. Same idea, but presented in a little bit more organized way. Here's the flow of our electrons, here's our anode, cathode, the half reactions of oxidation and reduction, and the fused overall reaction that is happening in the voltaic cell. We expect increase in concentration of magnesium ions in this jar on the left, and we expect decrease in the concentration of silver ions in the solution on the right. Okay, last example. Over here we have a voltaic cell with the electrodes made of silver and nickel. After checking table J and activity series of metals, we can see that the nickel will be our anode. It is more active metal, it is more likely to be oxidized. And silver will be our cathode, it will be a site of reduction. So the flow of electrons here will be from the right to the left. The electrons will be running away from the anode and towards the cathode. Let's write the oxidation and reduction half reactions. Since oxidation is taking place on the nickel electrode, we will be writing it here on the right. Nickel atom is getting oxidized, it losing 2 electrons, turning itself into the ion of nickel with the charge +2. And silver ion is getting reduced, accepting 1 electron, turning itself into atomic silver. But of course, 2 electrons lost and 1 received. That's not how it's supposed to be. So it will be 2 ions of silver that will be reduced by 2 electrons into 2 atoms of silver. We can predict that over time there will be increase in the concentration of nickel ions in the solution on the right. And we also can predict that there will be decrease in the concentration of silver ions in the solution on the left. Increase in the concentration of nickel ions will build up the positive charge in this solution on the right. And less of positively charged ions in the solution will eventually lead to build-up of the negative charge in the solution on the left. So our positively and negatively charged ions in the salt bridge will be traveling according to their attractive forces. Positively charged ions will be traveling towards negatively charged solution, and negatively charged ions will be traveling towards positively charged solution. We expect silver electrode to be increasing in mass, and we expect the electrode made out of nickel atoms to be decreasing and deteriorating. Now let's fuse the oxidation and reduction half reaction into the overall redox reactions that is happening here. Okay, here's the same information in the more presentable way. So here's a Voltaic cell, here is our nickel anode, the electrons are running away from the anode towards the cathode, silver, cathode is over here, the nickel is getting oxidized, the silver is getting reduced, and overall redox reaction that is happening here is written down underneath. Concentration of the nickel ions will be going up, the concentration of silver ions will be going down, the mass of this electrode on the left will be increasing, and mass of the electrode on the right will be decreasing because nickel is getting oxidized. Negatively charged ions running from the salt bridge to the jar on the right, and positively charged ions are running from the salt bridge to the jar on the left.